Hello, dear students. A very warm good morning to all. We were discussing about the infrared spectroscopy, and we have discussed about the fundamentals and the stretching frequencies of certain compounds like alkanes, alkenes, and alkynes. Now we are going to switch over to few functional group. You can see an IR spectra over here. This is the IR spectra of 3-hexanol. So the question is, what significant peaks between 4000 to 1450 per centimeter in the IR spectrum of 3-hexanol reveal the presence of an alcohol? So here the notable peak is this one, and we have already discussed the sp3ch peak appears somewhere between 3000 to 2800 per centimeter. Of course that peak will be here, and along with that you are seeing this particular strong broad peak. It comes somewhere 3350. This is the characteristic peak of alcohol, and this characteristic peak represent the OH functional group, and it appears somewhere in between 3650 to 3200. And when it is phenol, you need to understand it comes somewhere 50 to 100. Okay, so this is the striking point for alcohol. So if you recollect all, in addition to peak due to sp3ch stretching peak 3000 to 2800 per centimeter, spectrum has a strong broad peak centered at 3350 per centimeter. This peak is caused by the OH stretch. Examining many IR spectra tell us that OH stretch peaks typically comes somewhere 3650 to 3200 per centimeter. Phenol stretches typically occur 50 to 100 per centimeter, maybe lower than this. The peak is intense. Why the peak is intense? The peak is intense due to highly polar nature of the OH bond. Strength is due to polarity, and the broadness of the peak is due to hydrogen bonding. You need to note that point. Why the IR peaks are broadened? It is due to hydrogen bonding. The OH stretch of the carboxylic acid also broadened by hydrogen bonding. In the usual cases where the hydrogen bonding is supposed, the OH peak can be quite sharp. Next, the similar one with the OH functional group is OH is between oxygen and hydrogen. The same way it comes NH bond also between nitrogen and hydrogen. Of course, oxygen is the second most electronegative atom. Nitrogen is a bit less electronegative than oxygen. So what absorption in the 4000 to 1450 per centimeter range of IR spectrum reveal the presence of an amine functional group? You need to observe this graph. Let us talk about the striking points about the amine group. Like alcohol, primary amines are NH2. A secondary amine, R2NH, contain a polar bond to hydrogen that is capable of hydrogen bonding. In what ways are the IR spectra amines similar to or different from the IR spectra of alcohol? That's what we are discussing. What IR peaks are characteristics for amines? The number of NH stretches can be useful to categorize the amine as primary or secondary. A secondary amine gives a single peak, whereas a primary amine gives two peaks. This is because the two NH bonds of the NH2 group can stretch in symmetric or asymmetric fashion. Hope you are aware of the theory part. And when we speak about the spectra, primary NH2 and secondary R2NH, amines have NH bond. Tertiary amines do not have NH bonds. An NH stretch is much like OH stretch, so we expect to see it somewhere 3500 per centimeter, and NH bond is less polar than OH bond because nitrogen is less electronegative than oxygen. And from this we predict NH stretch to be less intense and the peak narrower because the hydrogen bonding is not that much strong comparing to OH bond. The spectrum agrees with our predictions. Let us go back to the slide showing moderately intense sharp NH peak at 3400 per centimeter. See this peak, it comes somewhere at 3400 per centimeter. It is sharp but moderate in intensity. In some cases, NH stretch is so weak it cannot be seen at all. Examination of many spectra reveal that NH stretch for primary amines typically occurs somewhere 3000 to 500 to 3000 per centimeter, and for secondary amines 3450 to 3300 per centimeter. So this value is to be noted. So we have discussed IR stretching frequency values for alkanes, alkenes, alkynes. What are the typical values that will hint about the molecular structure of the compounds. So you need to note down those values. So this primary amine, it comes somewhere 3500 to 3000, and if it is secondary, it comes somewhere 3450 to 3300. Next, the prestigious group of functional group, that is the carbonyl functional group, based on the IR spectra of 3-pentanone, propylethanoate and benzaldehyde. What absorption reveals the presence of carbonyl group? So let's recall these points. That is ketones, esters and aldehyde if you take. We learned that the intensity of the IR absorption depends on the polarity of the bond being stretched. And the carbonyl group is highly polar due to the large electronegativity difference between oxygen and carbon. So the IR peaks corresponding to the CO stretch are usually strong. Among the molecules that have CO, the carbonyl stretch peak is usually the most intense peak in the spectrum. So please observe this one. So I'll take three together. So here the notable points it is 3400 to this region, there are few peaks to be notable, and this region there are few peaks to be notable. Okay, so you can recollect back. The spectra of 3-pentanone and ethyl propionate have a strong absorption around 1750 per centimeter due to CO stretch. So the CO stretch, it matters, it comes somewhere 1850 to 1630. Ketone stretch peaks occur 1750 to 1705 per centimeter, and esters 1750 to 1735 per centimeter. These stretching frequency ranges overlap, and so it may not be always possible to differentiate between a ketone and ester based just upon the IR spectrum. That means only with IR you cannot discriminate the ketones and esters. The ring strain and the conjugation with an adjacent pi bond also influence CO stretching frequency. For example, CO stretch for the ketone conjugated with benzene ring typically occurs 1700 to 1680. So it decreases the value. not the intensity of the peaks due to the high polarity of the CO stretching bond. We have already discussed. The carbonyl stretching frequency are often the most intense peak in the IR spectrum. This makes them easy to identify. The weak absorption 3400 to 3300 per centimeter are also due to carbonyl, but generally too weak to be of any value. In general, CO stretches occurs 1840 to 1630 per centimeter. The exact CO stretching frequency depends the particular functional group, as we shall discover soon. So you need to revisit the spectra and check that what we have told is already there. So you listen to the values and the description, and please cross check with the spectra. This is for benzaldehyde and this is for propyl ethanoate and this is for 3-pentanol. So this 3400 range to be noted. You can see three spectra together, identify which one represent which one. For aldehydes, two aldehyde stretching frequency peaks are there. Sometimes they are called Fermi doublet. You could see, revisit the spectra. Aldehydes also have the carbonyl groups which appear in the IR spectra at 1740 to 1720 per centimeter. The lower, if it is getting conjugated, it will come to the lower frequency. The benzaldehyde IR spectrum also shows a pair of peaks 2850 per centimeter to 2750 per centimeter, which are absent in the IR spectra of ketones and esters. So how can you discriminate the spectra of aldehyde from ketones and esters could be understood by this point. Examining many spectra reveals these peaks appear somewhere 2850 to 2800 per centimeter and 2750 to 2700 per centimeter. This pattern is caused by the aldehyde CH bond stretch and is usually moderate intensity. The peaks around 2850 per centimeter may not always be distinct because of its proximity to the sp3ch stretches, but the 2750 per centimeter peak is usually quite distinct, and therefore the characteristics of the aldehyde, that's it, okay. So look at the carboxylic acid IR spectrum has a CO group and an OH group. Comparing to aldehyde, it's a carbonyl group which has a CO group and an OH group. So does it IR spectrum look like ketone with alcohol attached or something different? A thoughtable question. In the IR spectrum of decanoic acid, what significant peak of 4000 to 1450 per centimeter reveal the presence of carboxylic acid? You need to observe the spectra. You have seen the spectra of alcohol, you have seen the spectra of ketone. So here we can conclude that the carboxylic acids are different than just ketone bonded to an alcohol. The carboxylic acid functional group includes the carbonyl. So we expect a strong peak 1750 to 1700 per centimeter. It is to be noted only 50 range. Just like we saw for other carbonyl containing functional group. In agreement with this prediction, the spectrum has a strong peak at 1011 per centimeter. Examination of many carboxylic acid spectrum, this south 16.47 means the previous spectrum carboxylic acid. Examination of many carboxylic acid IR spectra reveals that the CO stretch occurs in the 1755 to 1700 per centimeter range or a bit lower conjugated. Also includes a broad peak. It represents the OH centered at 3000 per centimeter, as we learned before for OH and NH stretching peaks are broadened by hydrogen bonding. So by analogy, we conclude that the broad 3000 per centimeter peak is due to the OH portion of the COH functional group. This broad peak typically appears in the 3200 to 2500 per centimeter range. So we'll stop over here. Next we will switch over to amide. So please revisit the spectra and compare with the points. You need to note down those points and cross check with the spectra. And these every values, this is how, only I have cited only important values. So you need to by heart these values. There is no other way. So we'll work out few spectras, and you will learn much better when we take all NMR, all those concepts together. So this is the spectra of carboxylic acid. And thank you for watching.